In this lesson, we're going to take a look at isotopes. Now, isotopes are basically different flavors of the same atom. So if it's the same atom, that means we're always going to be looking at things with the same atomic number. Remember, that's number of protons. But we are going to change up the number of neutrons, and that's essentially what an isotope is. So we've got to look at two different things, atomic number and mass number. Now, mass number is not something that you've probably seen before. Atomic number we know. Atomic number is the number of protons in an element, and because atoms are neutral, it's also the number of electrons. It's a whole number. We can't have partial protons, right? That's sort of a big deal. No such thing as partial proton. You either have one or you don't. You can't have a part of a proton. It is different for every element. Remember, it's the number of protons that determines which element an atom happens to be, and because atoms are neutral, it's also equal to the number of electrons. Mass number is a lot different. It is the number of protons plus the number of neutrons. That's a number of neutrons there. So this is a sum. It includes two different things added together, gets us a total. Most periodic tables do not list a mass number. They do have what's called an atomic mass, which we'll take a look at in a minute, which is an average of all the different masses of these isotopes, but it is not the mass number. So because lots of elements can have lots of different isotopes, there's going to be many different mass numbers for a given element. But if we only want to refer to one of them, then we write the element name and then the mass number. So we can refer to carbon-12, or if we wanted to talk about the isotope of carbon that had another neutron, we could talk about carbon-13, or if we wanted to, we could talk about carbon-14. These are all carbon, and if you look on the periodic table, that's 6 protons, 6 protons, 6 protons, but to get to 12 total things in the nucleus, we'd need 6 neutrons, or 7 neutrons, or 8 neutrons. So there are different flavors or varieties of the same atom, or sorry, not atom, but element. The different atoms of the same element, these are all carbon atoms because they have 6 protons, but they're all different because they have different numbers of neutrons. And remember, neutrons determine radioactivity, and if these are different numbers of neutrons, these things might be radioactive or not. Turns out carbon-12, very, very stable, not radioactive at all. Carbon-14, pretty radioactive. So that extra couple neutrons changes it. So isotopes, elements of the same identity, which means same number of protons, but they have different numbers of neutrons. So we throw different neutrons into the nucleus. And I was just looking at these. So carbon-12, 13, and 14, this one's more massive because it has 2 extra neutrons, according to this one. This one's got 6 neutrons, this one has 7 neutrons, this one's got 8 neutrons. It's got 2 extra neutrons. That's a big deal. It's heavier, it's radioactive. Okay, so I said most periodic tables don't show us mass number, but they do have another number on them, right? We know about atomic number at the top. They have another number on them down here. Like that says lithium, and then it says 6.941. That is atomic mass. And it actually says that on the key. It says that's atomic mass. That is a weighted average of all the different masses of all the different isotopes of lithium. So if you happen to have a bucket of lithium atoms and you pulled out a handful, the average mass of that handful, each atom would have a mass on average of 6.941 atomic mass units. Individual atoms would be different from the average. Just like the class average in my Science 9 class is a C, individual students can have A, B, C's, D's, or F's, right? The average is not the same thing as an individual. Now, I am going to ask you to come up with the number of protons, neutrons, and electrons for different isotopes of different elements. So it says give the numbers of protons, neutrons, and electrons in carbon-14. You need a periodic table in order to do this. If I jump back to the periodic table on the previous slide, it says carbon, so that tells me here's carbon. There's its atomic number. It's got 6 protons, and because atoms are neutral, it also has 6 electrons. So the number of protons in carbon-14, well, there's 6 protons. Because there's 6 protons, there's also 6 electrons. Electrons is also equal to 6. 14, that's my mass number. Remember, mass number is equal to protons plus neutrons. which means I have 14 is equal to 6 plus the number of neutrons, and if I subtract 6 from both sides, I get the number of neutrons is equal to 8. So this has 8 neutrons in it because 8 plus 6 gets me 14. It's got 6 electrons in it because the number of electrons has to equal the number of protons, and it's got 6 protons in it because it's carbon. Carbon tells me it's got 6 protons. If it doesn't have 6 protons, it would not be carbon. Give the numbers of protons, neutrons, and electrons in sodium-23. Again, I need a periodic table for this. This periodic table is interesting because it actually lists stable isotopes mass numbers. So up here, there's a couple numbers going on. Like boron has stable isotopes when it's got a mass number of 10 or 11. We're supposed to be looking at sodium. Sodium-23, turns out sodium-23 is stable. This is the atomic number this time. I know that because I can read good. So atomic number 11 for sodium. So if we go back and take a look at solving this problem, we know that it's got 11 protons. I got that off the periodic table. Because it's got 11 protons, it also has 11 electrons. And because 23 minus 11 equals 12, I know that it's got 12 neutrons. Remember, 23 is equal to the number of protons plus the number of neutrons. So that's 11 plus the number of neutrons equals 23. Subtract like I did, and you get 12. Finally, an atom has 24 protons and a mass number of 54. What is the element and how many neutrons does it have? Well, 24 protons, guess I'm going to go to the periodic table and look for element number 24. Well, I found it. They go in order. Chromium has 24 protons. So I'm going to say, all right, it's chromium. It's chromium 54, so I better write that. I'm referring to that isotope of chromium. And it says, how many neutrons does it have? Well, 54 minus 24 equals 30. Again, that's because 54 is equal to the number of protons plus the number of neutrons. And so it told me 24 protons, so I subtract that off and I get 30 neutrons. So my number of neutrons is 30. Now a note on symbols real quick. You've seen me write P+, that's because protons have a positive charge. You've seen me write E-, that's because electrons have a negative charge. And you see me write N0, and that's because neutral neutrons have no charge.